Feather generate is used to generate the feathers onto a guide groom, taking the feather generation attributes from the skin. Feather generate is essentially a wrapper for feather data that provides some useful functions. There are 3 inputs: a guide groom, a skin mesh, and an optional conform mesh. Make sure each guide is only one primitive, since a feather will be generated for each primitive. The skin can be an arbitrary mesh. In the case of my flight and covert feathers, I used geo that was generated from the guides to paint on my groups. There are 2 outputs, the full feathers and the proxy feathers. If you generate proxy feathers, you will need to put down a null node to view them. There is an option to only generate a single feather, which can be useful for inspecting feathers quickly. This will keep the max feather length in mind while generating dynamic values based on length. The preview mode is the fastest way to view changes. It will only generate proxy feathers with proxy match turned off, and has cook times around a second for an 8,000 feather groom, while the full cook time is around 30 seconds. You should assign a generator ID to each feather generate node in your project. This gets used by later nodes to prevent feather ID duplicates when merging grooms. You can see the body feathers, flight feathers, and covert feathers are each generated separately, so they each have their own GenId value. You can have extra attributes from the skin applied to the feathers by listing them here. UV and CD are the defaults. I painted an attribute called white to the skin and added it to the sample skin attributes to specify which part of the eagle is bald. Upvector, or the feather orientation, can be manipulated in a number of ways. There are 4 general options for upvector. Skin normal will align the feathers to the closest primitive on the skin by sampling the normal attribute. Conform normal will align the feathers to the closest primitive of the conform geo input. If either skin or conform normal are selected, you get the continuous option, which means each point of the curve will sample the closest normal on the skin or conform. If turned off, you can select which point will do the sampling. Here you can see the big difference having a conform geo can make. Conform normal also has the option of attribute match. If the curves in conform geo share an ID attribute, the curves will only sample geo with a matching value. Curve normal will use the normal already on the curve points. I generated random normals on the flight curves to show this. I can also generate the normals randomly per point instead of per curve. Custom upvector will let you specify an upvector on the node. 0, 1, 0 means all the feathers will face up. For my flight feathers, I made a conform mesh by using the skin node on all the curves. You can add smoothing to the curve normals here, which can limit feather twisting if set to connectivity, or general orientation smoothing if set to proximity. Specifically meant for flight feathers, you can mirror the scale and rotation, and add an extra rotation to the feathers. The feather data section is the promoted parameters of the nested feather data. Most parameters are overwritten by the skin data, except a few, including the shading section. The dynamic settings will use the input guide length to determine a value per feather. This includes dynamic stem divisions, dynamic barb count, and dynamic barb divisions if barb div by count is also checked. The noise offset will get a unique value for each feather, so they will all be distinct. The rest of the feather data settings will be overwritten by the feather data on the skin. This concludes the overview of feather generate.